All right, so we are cruising along and we have talked about how we are going to be breaking down these glucose molecules and ultimately every one of those 6 carbons will eventually become a CO2, a single carbon dioxide that you exhale. Okay? You breathe in oxygen, you exhale CO2. This is why you are releasing CO2. All right, so we've gotten to a point where we've said we have this first step right here where we split this glucose in half in a process we called glycolysis. And we had already said we made a couple of ATP out of it, net. A total of ATP was 4, but we had to put in 2, so we got a total of 2 coming out. And when we broke this thing in half, I've added, you can see it's even gotten more complicated, but I wrote electrons here. So we said we're going to be following the electrons, and in the end, the electrons are really going to be what counts, because they're going to be, we said, where most of this energy is. But we'd said, okay, we got a little bit of ATP out of it. Now, so we'd had this pyruvate, the 3 carbon molecules. Remember, we've got 2 of those. You break a 6 into 2 3s. And so we're going to follow one of those 3 carbon molecules, pyruvate, through this pathway. And so the first thing that happens is something called preparatory reactions. And in the preparatory reactions, we don't make any ATP, but we pop off a CO2. So that CO2 right there, that's the first decarboxylation. Remember, we had said we're going to be talking about removing these carbons. And when we do that, we've liberated another 2 electrons. Now, what about those electrons? Electron is, by definition, a subatomic particle. It doesn't exist on its own. It is always connected to an atom, right? So in every one of these cases where we can see the electrons, we're going to have something called electron carriers that are going to be molecules that are temporarily picking up these electrons, and they're going to take it to the final step in this process. So we've liberated a couple more electrons, and we've produced our first CO2 in what we call the preparatory reactions. What does that leave us with? That leaves us with a 2 carbon molecule known as acetyl. So acetyl, so coming into the preparatory reactions, we had pyruvate, and then we end up with acetyl. And then what is going to happen is that acetyl is going to go to a cycle. And the old name for that cycle was the Krebs cycle. And it was named for some dude, right? So some dude named Krebs. So we had the Krebs cycle, but in modern books, I think your book, they refer to it as the citric acid cycle. So what is a cycle? A cycle means that around and around you go. Where you stop, nobody knows, right? It's around and around and around, continuing, right? So we have a 4 carbon molecule that is in this circle here, and we're going to add the acetyl to it. 4 plus 2, 6. We're back to 6 again. Don't ask me why. So anyway, that's the citric acid. And we're going to start decarboxylating. So we've said we've already gotten rid of 1 of those carbons. We're going to pop off 2 more. Kind of like a mad merry-go-round, popping the kids' heads off. That's one of my friends used to always say that. So it's not me. That was Claude Bailey in Tennessee. That was his way of explaining it. But it makes sense. So we take these 2 carbons and we add them to the 4, and then look, we start popping them off. There's 1, there's another, here and here. We're going to make some ATP along the way, and then we have all of these electrons that are being picked up by electron carriers. So at this point, we made 2 ATP here, and we go around the circle, you make an ATP, and then we said, oh yeah, we've got another one of these that's going to come in here, and you make another ATP. So hey, we're up to 4 ATP, and all of our carbons are gone, and all of those electrons have floated off to go somewhere else. And where are they going? They're going to the place where most of the action is. This is where we're going to make a whole lot of ATP. We're going to extract the extra energy in those high energy electrons. And so I'm sure you are on pins and needles waiting for that. And what this is called, this next step, is the electron transport chain. And okay, let me backtrack before I get ahead of myself. That first process, glycolysis, it happens in the cytoplasm, okay? So it doesn't matter if you're a bacteria that doesn't have mitochondria or whatever, you can do that. In you and I, then, those 2 pyruvates, what did they do? They found one of those mitochondria. And where did they go? They went into the center. They went all the way into the center in what we call the matrix. And these processes right here that I was just talking about, this is happening in the matrix. So all of this decarboxylation is happening in the matrix, and we make all of these electrons. Now, where do you think they're going to go? We said that we had the outside of the mitochondria, we had the cristae, and then that inner section called the matrix. We talked about the matrix, and we said something's going to happen in each of these parts. The electron transport chain is going to be occurring on proteins called cytochromes that are part of that cristae membrane. So the electron transport chain is embedded in the cristae, and this is where all the action is going to happen. All right, I'm going to stop right there.